Alright, we are learning today about antiderivatives, which is just the opposite of a derivative. So, for example, if we have a derivative of 2x, what would our original function have had to be? Well, it would have been x squared. Now let's check it. Well, the derivative would have been 2x. You have a constant, so like 2, it would just be 2x. That should make sense. Now, number 3, it would look a little trickier. X cubed would go to x to the 4th because the power would have to increase by 1. Now, my coefficient in the end should be 1. So what should my coefficient out in front be? It would have to be 1/4. So when I check it, 1/4 times 4 would go to my 1. Trig functions work the same way. We'd have sine of x. And this one right here, 1 over x cubed, well, that's the same as x to the negative 3rd power. So it would be x to the negative 2nd. Now, how can I get my coefficient to be just 1? Well, I would have to have 1 over 2 being negative. So negative 2 times negative 1/2 will give me the positive 1 that I needed. Now, if this were a test, you would get a 5 out of 10 on this test. Because each one of these, you need to have some constant at the end of it. Because the derivative of any individual number is nothing. So we can have any single number out here, so you always must remember these plus c's. Now, here's just a way that you can look at the general power rule when you take a derivative. So if f prime of x equals x to the n, the exponent of the antiderivative would be n plus 1, and it would have to be divided by that same exponent, n plus 1. Alright, so that's a general rule. And here's another thing. If we talk antiderivative, or if I say integral, that really means the same thing. The integral, here's the notation that we use, and we say of a function dx. All it means is with respect to x. So really, that right there just means find the antiderivative of that function with respect to x. Because there's sometimes you could have functions that have multiple variables in there. So the way these will work, what is the... Well, I'll tell you what first. Pause the video, see if you can figure these out, and then hit play when you're ready to get going again. Alright, so the antiderivative of 3x. It's going to be something x squared. Whether I use the power rule or whether I just kind of intuitively know, I need my coefficient out front to eventually be 3. So I would need 3 over 2 for this to multiply out to give me 3. Or if I went by the general power rule, I would have to divide what I had before by my new exponent. Same thing over here. I would need to be x to the 4th. I had a 3 out front, but my new exponent is 4, so I should divide by 4. Now, I almost forgot over here, to make sure you don't forget either, that plus c at the end, because I can have a constant at the end too. Alright, number 3, which antiderivative, what antiderivative should I get when I take a derivative? I get 0. Well, that would be any individual number, so my answer is just c for that one. Number 4 here, all I would say here is, this is 2 times x to the negative 2nd power dx. So my antiderivative should be something x to the negative 1st, and I want my answer to be a positive 2, so that means it sort of needs to be negative 2. And then again, plus c at the end. Now, all of these here, these are indefinite integrals. These are what we would call a general solution, because we can have many different answers based on what our value of c is. So, what we're going to do here is finding particular solutions, which means we have a specific value for c. So the way to do that is I'm going to start the same way, and I'm going to take a derivative. Take an integral of my f prime of x. So that's how I'm going to set it up, and I'm going to solve it. So my integral of 3x squared minus 1, the integral of that will be x cubed, just x cubed, because it will give me 3x squared, minus x, and then plus c. This right here, again, would be my general solution. My general solution. Find a particular solution. What I want to say is, this really is what f of x is. F of 0 would be if I plug in 0 of that. So 0 cubed minus 0 plus c. And it tells us f of 0 is 4. That means my c value would have to be 4, which means my final answer would be x cubed minus x plus c divided by a particular solution. This is what I want to find, is a particular solution. So all you need to do is plug in that initial value and solve for c to get your new answer. And that should not say c there, of course. this should now be plus what I just found for C, which was 4. So here are 2 more examples. Give them a try, pause the video, and come back to check your answer. Alright, you should get f of x to number 1 is the integral of this equation, 8x cubed plus 5 dx, which will equal, it should be something x to the 4th. It would need to be 2x to the 4th. If I want to say that as 8 divided by 4, 8 divided by my new exponent 4, that would work, plus 5x plus c. Again, I would then say, well, f of 1 equals, if I plug in 1 for all these, plus 5 times 1, it should equal negative 4. So I should get here 2 plus 5 plus c equals negative 4. C will give me negative 11. So my final answer should be that f of x equals 2x to the 4th plus 5x minus 11. Now number 2 is a little tricky just because you have to do everything twice. In this one first, the antiderivative of f prime would be just, or f double prime would be f prime. So I take a derivative of x squared, and I will get 1/3 x cubed plus c. It tells us that f prime of 0 equals 8. So I'm going to plug in 0 for this, and I should get 8. So that means c is 8, and my final f prime function, f prime of x, is equal to 1/3 x cubed plus 8. Now I need to do this antiderivative yet again to find what f of x equals. So it should be the integral of 1/3 x cubed plus 8 with respect to x. And that would be, well, this is not going to be x to the 4th power, to have 1/3 and then divided by 4 again, so 1/12 plus 8x plus c. I then would plug in f of 0, and it should equal 4 here, it tells us. So I'm going to plug in 0. 1/12 times 0 to the 4th plus 8 times 0 plus c is equal to 4. So again, I get c equals to 4 with that. So my final answer for here is that f of x will equal 1/12 x to the 4th plus 8x plus 4. And that's the beginning of a long strand coming up of fun times with antiderivatives and integrals.